So thank you everybody for joining both Panzura and OneTier for achieving CMMC 2.0 certification. My name is Glen Shok. I'm VP of Product Marketing at Panzura. And with me, I have Tabor West from OneTier. Tabor.
Hello.
Hi. Okay, so let's talk about the agenda. So we're going to keep this simple and straightforward. Not that simple. It is government-based and it is zero trust, but we're definitely going to keep it straightforward. We're going to talk specifically about CMMC and what it takes to pass an audit from the PAOs. So OneTier has a CMMC kind of in a box solution, and we're going to talk about each of the components of that solution. And as part of that, we have CloudFS. I'm looking at the attendee list, and a lot of you are existing CloudFS customers, so you'll know my section of it. But for you, it is what else does it take to reach CMMC 2.0 compliance. The majority of this presentation is not going to be a Panzura presentation. It's going to be from Tabor about OneTier solutions and what it takes to get that certification. So with that, I'm going to pass it off to Tabor.
Thank you. I'm Tabor West, and you'll have to excuse me here. I sound like a frog because I've been sick for a couple days. My child bestowed upon me his gift there. But if you can all hear me, I'm an engineer in multiple disciplines. Came out of the U.S. Navy, 15 years in Department of Energy and NNSA in nuclear non-proliferation. Another 20 years in industry here before Chris Romeo and I started OneTier some years ago. So I'm very steeped in the minutia of government bureaucracy, paperwork, and attestation that goes along with these systems. I am one of the original architects of CyberNet on the classified side. So with that in mind, what we set out to do was create a system, structure, and framework that would align itself with CMMC 2.0. This also includes CSF, which would be NIST 853, which then has migrated into NIST 800-171, 172, and it's attested under NIST 800-207, which would be CMMC 2.0. This has multiple levels. So this is where it gets complicated for the end user and where we try to simplify this down and make it achievable. So when you look at Zero Trust, you functionally see a set of particular pillars that they follow. It used to be 5. It's expanded out under 2.0. But each one of these is broken down into the users, meaning authentication, access control, the devices themselves, how those devices are accessed, how they access the network, whether any of this is automated or orchestrated, who does or doesn't lay hands upon it, what the data is, where the data is structured. This is where Panzura primarily comes into focus because we have criticality around identification, protection, backup, restore, and visibility of data. The application workloads themselves, how we can secure them, containerize them. The most critical component of all, which is the network infrastructure, because virtually everything is accessed via network in this day and age. And then the visibility and analytics that come into play around all of these pieces put together. All right, let's move into the next slide. All right, so to address this, what we've done is we've put together a modular portfolio of components, and they work in a hierarchy. So functionally, we start with risk engagement. And what risk engagement is it's an automated set of penetration testing tools that then correlate real-time data on the organization and then bring this all down into a system where you can catalog it, you can mitigate it, you can identify it, and ultimately you can attest to it. And if you're under CMMC 2.0 level 3, you have triannual federal audits on your data. So this is something you will have to do. So what we're trying to do is make all this extremely simple, streamlined, using data tools to collect everything, prompt you as to what's needed, literally walk you through the process of being compliant. Because when you audit, you need to be 100%. It's not a, well, we're close enough, the auditor will fail you. So you have to prepare 100% package and turn it over to the auditor. Okay, so once we've moved through that, we go down the chain. And functionally, this one's a little bit out of order, but I start with the networking component. So we implement a highly secure software-defined networking component. That then accesses our data structures. The data structures would reside within Panzura Cloud FS, and they would utilize the Symphony analytical components to then secure that data, compartmentalize it, identify what the data is, who the users are, where it'll flow. Then we take the apps and we secure and containerize the apps within kubezrt. So this is a secure implementation of Kubernetes. This virtualizes the entire structure. Then we take all of that and we use our anti-cloud orchestration to automatically build the cloud structures in your chosen cloud environment. It could be Azure, it could be AWS, it could be GCP, it could be Oracle, it can be on-site data centers or off-site, so on and so forth. Very flexible, but the idea being to understand the exact usage, the costing involved, when, where, what, why, and be able to automate that so that cloud workloads can go up, they can come down, and they can functionally be tracked at all times.
And these
Then we
workloads
move
are
into
typically running just regular public cloud, right?
right. So literally think about this from regular public cloud instances all the way through highly secure DoD 365 instances and DoD AWS, right?
Awesome.
Because data has to move from the lowest classification, publicly available, to the highest classifications, which are above IL6. And so to do that, one, we have to be able to protect the data at those levels each step of the way. Two, we have to be able to automate the movement. And three, we have to be able to report everything that occurs with that data classification up and down the chain. Because data goes up, data does not come back down. So we don't want to stick all the data up there. We want to know exactly what data goes up there and why it's going up there, who has access to it, and more importantly, when they have accessed it and for how long. And that comes to the user control portions and being able to audit this. So in risk engagement, what we're doing is we are blending together a whole host of different tools that would each normally be done separately by different teams and bring it together to generate a complete dashboard with a risk score, with an actual remediation checklist that's plannable and monitorable, continuous updating of where each score is within each control value, the amount of money associated with that control value, the percentage of achievement along the way, and automated backup of that process, meaning that when you go through and you say we've identified specific things that need to be patched, we've identified documentation that needs to be put in and attested to, then you go through and scan, it validates that that's the case. Say it gets exported to a tool like Drata, then we're fully integrated with those tools. So we can export that data automatically in there and intake other data. And then that will go through and it will literally prompt the user to say, hey, you've got A, B, C, but you're missing D, E, and you have F and G. Here's the templates. Go ahead and fill this data in and let's rescan. So that's functionally how the system works. I won't jump into massive detail, but it's a very large platform. It runs both outside and inside, and it simulates the attacker.
That's awesome. If there's any questions in real time about any of these sections and how it pertains, feel free to ask the questions in the chat. And again, we'll address them in real time. Okay?
All right. Now, any cloud orchestration is the closest we can get to a holy grail of cloud deployment. Cloud deployment is extremely difficult. The cloud providers change their systems without notice continuously. I have been there since the very beginning. I helped Microsoft deploy the first Azure data center on the Columbia River. This is more than 30 years ago. And even I go and log into Entra and go, where did you just move that menu? Okay, so based on that and knowing that we all have this pain, what this system does is it's a Terraform base. It's fully automated. It allows you to create entire cloud environments in a Visio-like drag and drop manner, assign all the variables to it, see real-time pricing before you deploy the environment in all of your cloud subscriptions. So literally compare the price of this environment from Azure to AWS to Google, tell you what it's going to cost in each one before you deploy, has an automated AI-driven checker on the system. And then once everything is good, save it as a template so it can be reused or modified, and one button deploy it up into the cloud. Now, looks like we have a question.
I answered it.
Okay, perfect.
Yeah, the slides will be available. The replay will be available on Panzura's website. If you want the slides, just email me, gshok@panzura.com, and I'll get you PDF copies of the slides.
Perfect. Now, what we're seeking to do with this tool is take massive amount of people hours and reduce them down to minutes. So think months of work that can be accomplished in hours or less with real-time costing, high security and encryption involved, and the ability to track and trace everything. So if an auditor comes back and says, how many instances, where are they? You can instantly pull it up on the dashboard and say, here's everything running, everything quiesced, all of the templates. This is where all the data is located right now. This is what's live and this is what's passive. A lot more to these tools, but obviously that's the big picture in a nutshell.
We do have a question about data classification as a problem, and then I won't read the rest. I think everyone.
Right. So
go ahead.
We do have AI-driven tools. So we have tools that can actually go through using, say, framework and identify data. Now, I was a derivative classifier in the federal government. I know this inside and out. So I'm not going to say that there is a holy grail here of automated classification, but what I seek to do is do the majority of the classification using large language model, and then have that presented to the classifier so that they can vet the data versus 1,000 pages of documentation, go through and categorize that data and rapidly speed up the classification priority of each data set so that we're not overclassifying and we're not underclassifying and we're not dumping too much data, which then can't be tracked. We also have the ability to manipulate data that is encrypted without decrypting and exposing the data until an ETL out of a database is actually done, in which case we can use other tools to maintain that. So this is a huge leap forward in data handling right there. And
Symphony does have part of the question. Yeah, Symphony does have the ability to do tagging within the extended attribute section of the files, which is supported by every operating system. So that is one way that we can put in metadata into any files and add that kind of classification within extended attributes. And of course, Symphony can help create a metadata catalog where that becomes searchable without actually scanning through the file system. And we can have those conversations. John, hopefully that answers your question.
The Veronis, right?
Yeah. I didn't want to read through that.
So, yeah. We have new tools.
Yeah.
You're going to like them. And it's, by the way, everything here is continuous development. This is all CI/CD pipelines. It is all DevSecOps. And much of it is SaaS driven. Now, that doesn't mean it can't be air gapped. I don't prefer, but we know that pieces have to be cut off into enclaves. And so the idea is to create a classified area network and a classified area network, be able to segment, rejoin, and have particular indexes, which are things that Panzura can assist with in terms of ordinating the data between two sets and making sure that everything levels up when they're reconnected.
Can you go into it for a second? You mentioned the term enclave. Can you explain to everybody what that is and why it's
All
important?
right. So in the DOE and DoD world, the two areas where intelligence community as well, I won't exclude them because they do all kinds of fun things. They have to play back and forth between them. But generally, projects in terms of both classification and need to know, just because a person has a clearance does not mean they necessarily have need to know on a particular set of data. So if we have to take data and we have to put it into different enclaves, we can then track what those enclaves are, those particular cabinet areas where the data is, and then we can control who has access to the data based on their classification level, based on their clearance, based on their need to know. So that's that horrible paperwork chain that goes along with trying to protect everything. And what we want to do is also automate that so that the tracking is automated, not necessarily taking the decision away from a person. We don't want to do that. What we want to do is monitor, track, and alert on a continuous basis of when a violation is occurring or if someone shouldn't be there or have access, if that makes sense.
Awesome.
Now, falling within that is kubect. So this is taking the application stack, containerizing it, and fully securing it. So this is a container that has its stealth networking, fully encrypted mutual TLS AES 256-bit dynamic network system incorporated on top of the shell with all of the encryption, authentication, PKI, Kerberos, everything in that container needed to operate that container built into the container. So this allows complete isolation of the application. This is very important, one, for classification of data and operations, but two, for investigation of applications that we don't necessarily trust. And in zero trust, you don't trust anybody. Zero trust. Don't trust anything. Authenticate every single time. Re-authenticate every single time. Least possible permissions, least possible access. So our implementation of this allows for these containers to be clustered, placed wherever moved, and investigated without them harming the rest of the infrastructure and without exfiltration of data if somebody has slipped a backdoor in there. All right. Okay, so let's get into stealth networking. Stealth networking is very unique. This has come out of a very, very long-running project, think decades, where we're trying to create the most dynamic overlay software-defined wide area network. It doesn't matter what the underlying network structure is. You could be Cisco Polo, you could be on dry copper pair, you could be satellite link. I don't really care. I need a route and I need an access. And I will turn that on and off automatically at high speed. It will multi-channel, it will multi-route, fully encrypted. It obfuscates all the traffic. It obfuscates the entire inbound side of the firewall. You don't see the ports. It's all policy controlled and policy driven. It's multiple points, and they automatically kill and instantiate new connections. So the system learns the entire route map of where it can go, and it automatically picks the routes it's going to use to get to the destination. So this is a true edge and core network. You can move edge to edge, you can move edge to core, core to edge, or any combination in between, and you can define where those core and edges are. So every participant in the network becomes a node in the wide area network, and that means IT for people and IoT for devices. So everything is nominal node. This works beautifully with Panzura in terms of the mesh and the core and the edge. And so what we get is like dynamic VPN tunnels that are multi-endpoint, multi-channel versus fixed locatable endpoints. And that's kind of the best description. It's very lightweight, it's very easy to implement, very easy to track, and extremely secure.
So specific to this deployment, it acts as a secure overlay network to whatever the customer already has.
Exactly. So you've got a network channel, and what we're doing is we're co-opting that network, the physical network, and we're inserting a virtual network through it. So think the highway is laid down, and you're in the Ferrari using the highway, and you can automatically choose any route you want through the interchanges and various highway segments as you move. Basically, leaving the physical network there, you're traversing virtual tunnels across the top of that, and those tunnels are dynamically created. Now,
While a pen test could show holes in the underlying network,
yes,
having this ensures that there's no holes in the network that needs to be CMMC 2 compliant.
my assumption is always that the physical network is compromised. And I've actually been working with government agencies while they've been compromised, while we're going in and doing investigation and whatnot. So just assume on your networks that the physical networks are compromised
Perfect.
at all times.
Okay, so let's talk about the underlying storage. Those that have viewed their already Panzura customers and know CloudFS, bear with me for a moment. If you have any questions, again, I am monitoring the chat. CloudFS is a hybrid cloud data management platform, right? This portion of it is a global file system, essentially. We connect to a back-end object store, and that object store could be on premises, it could be on cloud. For this presentation, let's talk about it cloud-based, right? Since that's what Tabor brought up. So it could be S3 on the back end, Azure Blob, GCP, all that. We support CloudFS nodes globally, right? What that means is you can place them on premises, you can put them in cloud. And what we do is we'll use that secure network to connect all of them within a mesh. So they all communicate to one another, but they also communicate to the backend object store. Every CloudFS node is essentially an edge device with CPU and memory and cache. The reason why everything is cached at the edge is because what's important to this yellow region, the hot files that are important to this yellow region, are different than the hot files that are important to this red region. Yet they all share the same entire global file system. All commits are made to the backend object store, but the users locally to this red region here are probably working on different files at different times than yellow. Right? So we want to give local feeling performance to these users, but what we also want is a single view of the entire global file system. What this local caching also allows for is that we can pin data and we can actually go offline from the backend object store. So you could basically be within an air-gapped network temporarily while local users are using just the files that are cached locally. And because we're a global file system with write locks owned by the local nodes that kind of created those files, right? The rest of the global file system will be able to see those files. They'll be able to open them for read-only, but they will not be able to do commits, right? So there's no versioning here within this global file system. There's no potential for overwrites because of the way that we handle our write locking. The write locking occurs within this mesh network. So let's say a file wants to be opened within this yellow region. If the write lock is owned by red, the yellow CloudFS node will need to talk to the red, request the write lock. It will receive the write lock. It can make changes that are then committed to the backend object store. And if somebody within the red region real time wants to open that file for read and write, they'll have to take the write lock back. It ensures consistency globally, right? And make sure that there's no versioning on the back end, but this is an immutable file system. So with an immutable file system, that means that every incarnation of that file, every change to that file is stored within the backend object store. So you can recover to a previous version if, let's say, something bad happens, like say you get hit with ransomware internally or malware, right? And those D, E, and F blocks, let's say, were compromised and it's a complete re-encryption of that file. You can just go back to version C of that file and recover instantly. You can recover on a complete file system basis, or you can recover on a file by file basis. So that immutability provides that kind of protection that's required for CMMC, that's required for the cybersecurity framework. Recently, Gartner has come out and named Panzura, as well as very few other companies, part of what's called cyber storage. Right, so CloudFS is now included within that cyber storage concept that merges the cybersecurity along with traditional storage. And it's this immunity to ransomware, or the quick recoverability of the system from ransomware, that puts us within that category, and really easy to put into environments that require zero trust. Some other components to CloudFS that help this scale are Panzura Edge. Right? With Panzura Edge, you can get access to the global file system while maintaining all of the required audit capabilities. So you don't need a VPN. You can go in, you can check out a file. In the next version of Panzura Edge, we will have real-time locking as well. Right now, it's check-in, check-out based. But there will be real-time locking as well. This can work from a browser. We use this for secure file sharing as well. If you have a contractor and they need access to files within the global file system, and you want to give them access to just a small portion, you can put those within Panzura Edge. And when they check out those files and they make edits, all of that can be audited. And it is audited through Panzura Data Services. So we have a search and audit capability specifically around audit that's relevant to this conversation about tracking data exfiltration. So right now, what we can do is we can flag any request, Edge Office connection incoming. Yes, it is. There was a question in the chat about an Office connection incoming, and it absolutely is, yes. I can give you a time frame, John. I think you're probably going to email me about something else. So I can give you kind of like when that's coming within the roadmap, but I know it's not that far out. So we can flag any type of data exfil that's happening. Let's say that you want to make an alert. On average, Glen Shok, that's me, touches 5 files a day. If all of a sudden I'm at 30 and then 100, relatively quickly, that's probably a data exfiltration action. Or I'm actively introducing ransomware or malware. And so that will ensure that that gets flagged to the admin, and we can either automatically shut off their service, or you can just get an alert and react. Very shortly, we're about to introduce an AI engine that will automatically track every user for their norm and then flag if they're outside the norm. So basically, we're doing that kind of Varonis type of work on CloudFS specifically to ensure that any weirdness that occurs within the file system will at least get a flag, or you can go to the next step and just cut off their access to the file system itself. The last bit is detect and rescue. We want to automate the alerts around being hit with ransomware. CloudFS knows what it looks like when it's being hit with ransomware or malware, and what the back-end systems do immediately when that happens. So we have that intelligence internally, and we can interdict, we can cut off the user that's causing this, we can do an alert, and we can roll back, right? That's the rescue portion. We can roll back the files that were impacted with ransomware or malware, or we can, again, bring back the file system itself if that corruption happened overnight and nobody paid attention to the alerts. Okay, back to Tabor.
All right, so secure access, obviously, last but not least, this is the ability to utilize multiple different single sign-on options, encryption options. So basically, what we're doing is we're not reinventing the wheel. We're incorporating the various different logon and user authentication components from both on-prem systems and cloud systems. So for instance, we can take a typical set of credentials like Microsoft SQL admin accounts. These are notorious. They can't be multi-factor under a traditional system. We can actually tokenize them and make them multi-factor. So the idea is to secure everything and everyone and have them specifically authenticate and disconnect as soon as their access is no longer needed to the data. And that means within a session, not when they retire or leave the company. This is, by the second type of thing. But also incorporating very robust monitoring tools, systems that have actually been in the DoD for 3 decades, using AI systems so that we can monitor movement of data, data flows, potential exfiltration, so on and so forth into the system, and do this both in the cloud and on user devices and IoT. So this kind of caps out the bubble around the security system, or the outer shell.
So what does a typical engagement look like? Let's say, and we have a few Panzura customers on the line here. Let's say that they want to go after government business and they need CMMC 2 certification, and they already have CloudFS on the back end. What does an engagement look like, soup to nuts, to get this going from OneTier?
We always start with a discovery session, because you have to map out exactly what the customer has and what they're going to require. And then we work with the customer, identify all the systems, document those systems, do the prerequisite scans, do the identification, come up with a map. That map is then going to allow you to expand out to what systems are needed, when they're going to be needed, to what degree. One of these components, we have this slide up here right now, is Secure Access Browser. This is very unique. It is not a browser replacement, but it's a secure browser plugin. And it acts like a firewall on, right now, Chrome, Edge. It's expanding soon to the rest of the browsers. But this gives you the ability to control the browser side, which is very important, because when you go out to a website, and most services are through the web, at this point, you're leaving the secure enclave of your network. You're going somewhere else, and you're deliberately doing it. And this is how the bad guys get in, because they know you're going to go out and retrieve something specifically from a website. So if they can spoof it, they've got you, even when you have the highest security controls. So what they're doing is they're grabbing your traffic and redirecting. This stops all of that. This acts like a super portable firewall. It has full policy control. It's fully definable. Everything is monitored in the dashboard with alerts. Very simple to deploy, very lightweight. It'll actually accelerate browser data. And here's a key. This includes a secure DNS, a real secure DNS, like think Cloudflare-like, where all the traffic is routed through. So a huge amount of this can be stopped all the way out at the border before it even gets in to the network, and into your browser. So another component in protecting the overall sphere in the modern, let's say, workspace.
Okay. So if somebody wanted to engage OneTier, how long would it take them to get to, let's say an average size company, right? We're not talking JP Morgan, right? How long would it take to get to the components necessary to pass an audit?
So the initial scans are very quick, right? And that creates a baseline. And you can go down and see all your scoring by category, by control value, percentages, and whatnot. That's going to determine the timeline from that point on, right? Start PMing it. All the work that everybody loves to do, the PM work, right? So at that point, some things can be immediately addressed from the penetration test. Some things are going to be documentation, and that means creating the document, pulling in the templates, populating them, so on and so forth, then going through the internal audits. So think anywhere from 4 weeks to 12 weeks on a typical engagement of pulling in the right tools and actually engaging it. Now, I've been with lots and lots of customers, and they'll be at it for 6 to 9 months trying to do it manually, and they'll only be halfway or less through their audits.
So engaging you early, you can implement the right tools. You're going to cut your time frame down by half or 2/3, realistically.
Or more. Yes.
Yeah. Okay. We're open for Q&A. Hopefully ask some of the questions that were important to everybody. Usually timeline is the number one question. Cost is a separate conversation, probably a more private one. But are there any other questions? Please throw them up in the chat. Hopefully this was an informative webinar around how to get the CMMC 2.0. You do have my contact within the chat as well. It is gshok@panzura.com. You can reach out. I'll get you in contact with Tabor at OneTier. If you're an existing Panzura client, if you're not, it's a whole solution. We'll make sure that you're ready to do business with the government.
Absolutely.
All right. If there's no other questions, again, this will be available for replay online. And if you do want slides, feel free to reach out. Thank you, everybody.
Thank you, everybody.